Okay, I'm going to start tying forces into motion a little bit more, and I'm going to start by talking about balance and imbalance. So balanced situations are also known as equilibrium. And it means that the forces are balanced, right? Forces are balanced, and something can be in equilibrium or it can be stable. It can still be moving when it's balanced, but that means that its speed is not changing. So there's a couple terms that you're going to see that indicate something is in balance. So constant speed, right? If the speed is not changing, that means that you are in a balanced situation. Another word that might mean balance would be at rest. Not something that's coming to a rest, not something that starts at rest, but that's continually at rest. So if something is continually at rest, it's not moving, and if you're not moving, then it's certainly in balance. If you're moving at a constant speed, it's also in balance. Balanced means that you are moving at a constant speed, so therefore, if your acceleration's the change in velocity over time, your acceleration has to be zero. So you are not accelerating. And because, as we'll learn a little bit more later, net force is tied directly into acceleration, net force is actually going to be equal to mass times acceleration. So if your acceleration is zero, your net force is zero as well. So anytime you see net force zero, that means that you are balanced. That means you are moving at a constant speed. Now, you've seen the kinematics equations before. I'll put this up here again. So think about this. D equals VIT plus 1/2 AT squared. Anytime that acceleration is going to be zero, this whole second half of the equation disappears. In addition, your initial velocity is the same as your final velocity because your velocity is not changing. So you can use the constant speed equation whenever you know something is balanced. Distance is equal to velocity times time. This is always going to be true in a balanced situation where your acceleration is zero. Not an equation necessarily on its own on the reference table, but it can be derived from these kinematics equations here. Constant speed. This means a whole host of other things and can be applied throughout the course. Some of the stuff we're not going to get to for a while, but let's think about it this way. So if your net force is really a resultant, right? So the result, I'll say the resultant of the forces is zero. That's one thing that's true when you're balanced. A couple other things. If your speed is not changing, your kinetic energy, which depends on your speed, is not going to be changing as well, so it's going to be constant. Anything that depends on speed, when speed doesn't change, is also going to be constant. Something else that is going to be impulse. Now, impulse depends on force. It goes by the letter J. We're not going to get to this for a while, but it depends on force, so therefore, because it depends on force, your impulse is going to be zero, and that has units of kilogram meters per second. So several things, once you figure out your constant speed, several other things fall into place as well. Now let's divide this from unbalanced. So in unbalanced, you're not in equilibrium. It means that you have your forces that are acting on an object are not balanced out. So you are going to be accelerating. Now, you don't necessarily know what that acceleration could be. You could be speeding up, or you could be slowing down. The specifics will depend on the actual problem that you have. Now, you can also be at rest when an unbalanced situation, but only for an instant. So if you have an unbalanced situation and you start at rest, that means you're not going to stay at rest for more than that very small instant of time. That's because your acceleration is not zero. you definitely are accelerating. In addition, because net force is mass times acceleration, net force is not going to be zero either. So it's like flip sides of a coin. Are you balanced? Are you imbalanced? And most of the motion problems that we see are going to come down to one or the other of these situations. Kinetic energy, for example, is not constant. That means it's changing. Kinetic energy is changing. Impulse, for example, is not zero. Kilogram meters per second. Your momentum, here, balance forces, momentum depends on velocity. So your momentum is also constant. And that goes by lowercase p. But here, momentum is changing, for example, if your velocity is changing. Lots of things, but get used to, in particular, one of the most important set of words you can look for these in problems is constant speed, because that tells you something very important. Is it balanced? Is it unbalanced? Thank you very much for watching.